American Physics Olympiad, year 2012, F equal MA. First round. Problem 23. Which of the following sets of equipment cannot be used to measure the local value of the acceleration due to gravity, g? There are 5 different sets. Solution. Let's examine all these sets. A spring scale which reads in force units and known mass. This set could be definitely used because if we divide weight by mass, we will get g. So it means that this is not correct answer. B. A rod of known length and unknown mass and a stopwatch. This equipment could be used if we take this mass and use it as a pendulum with a known length. We can count what is g using period and using length formula. So this is not correct answer. C. An inclined plane of known inclination, several cards of different known masses, and a stopwatch. Here we definitely need to know what is the height from where these cards can be pushed, or the distance they travel, but we don't have measure for that, so this is definitely cannot be used to measure what is g, so it means that this is correct answer. D. A launcher which launches projectiles at a known speed, a projectile of known mass, and a meter stick. This could be used for g because we have formula to find what is maximum range if we know what is initial speed. So for angle 45 degrees we can get the maximum range, but here we can repeat our measurements for different angles and find what is the maximum range and find what is the g using this known formula. So it means that this is not correct answer. And last one, E. A motor with a known output power, a known mass, a piece of string of unknown length, and a stopwatch. This one is tricky because we have a motor with a known output power, and we can hang this motor using string and turn it on and count what is the total time for this motor to pull this up the string. It means that we know what is power, we know what is total time, so we can get total energy multiplying power by time, and this energy equal mgh. So mass is known, it means that we can find what is gh. And the second thing we can use this motor as a pendulum, and we can measure what is a period of oscillation for this pendulum, and from this period we can find what is g over L. So it means that from first experiment we can find what is g multiplied by L, and from the second experiment what is g divided by L. From here we can find what is g and also what is L. So it means that E is not correct answer, and we have only one correct answer, is C. Problem 24. 3-point masses M are attached together by identical springs. When placed at rest on a horizontal surface, the masses form a triangle with the side length L. When the assembly is rotated about its center at the angular velocity omega, the masses form a triangle with a side length 2L. What is the spring constant K of the springs? Solution. First, let's draw the picture of this triangle. When this construction rotates with the angular speed omega, the length of this side B equal 2L. Also, we need to count what is the length of this side A connecting any mass with the center of triangle. This A from the geometry equal L over cosine pi over 6 or 30 degrees. Now let's write the equation for centripetal force which acting on each rotating mass. Because all springs enlarged by distance L, the force of tension in each spring equal KL. And this force directing in this direction, and for each mass we have total force composed from two forces, and we need to count what is the projection of these two forces on direction of this A part, which is 2KL multiplied by cosine 30 degrees or pi over 6. And from other hand, this force must be equal to centripetal force, which is MA omega square. And A we already counted. So when we put this in this expression, we can cancel L, and finally we can count what is K. K equal M omega square over 2 cosine pi over 6 square, which is 2 over 3 M omega square. That's answer C, correct one. Problem number 25. Consider the two orbits around the Sun shown below. Orbit P is circular with radius r. Orbit Q is elliptical such that the furthest point B is between 2r and 3r. And the nearest point A is between r over 3 and r over 2. Consider the magnitudes of the velocities of the circular orbit VC, the velocity of the comet in the elliptical orbit at the furthest point VB, and the velocity of the comet in the elliptical orbit at the nearest point VA. Which of the following rankings is correct? Solution. From these 5 equations we can guess the result and check result C. If we compare 10 VB with VA, we can say that the furthest difference could be when distance from A to Sun is r over 3 and furthest is 3r. It means that the biggest difference between these two distances is 9 times. It means that due to angular momentum conservation, VA multiplied by 9 must be greater than B, and we have 10 VB greater than VA. So this is a correct one. And now let's check VA greater than VC. If in this point we have a circular orbit on a small distance, we have this speed VA must be greater than VC, but this orbit is not circular, it's elliptical. It means that this speed must be greater than for circular orbit. It means that in any case VA must be greater than VC. So C is the correct answer. It means that we even don't need to check answer A, B, D, and E.